Hello dear students and welcome back to Diksha Vedantu YouTube channel. So today is day 12 and we are going to discuss a chapter from your science which is basically light chapter, and from that chapter we are going to concentrate on reflection of light and spherical mirrors. Okay, so if you are eagerly waiting for a physics chapter to be completed, then here I am to help you to understand this complicated chapter. In my opinion, even though it is not so complicated, many students feel this difficult, especially there are a lot of diagrams are involved, drawings are involved. So don't worry, I am going to help you with everything, what you have to remember and how you can answer question based on these concepts. So without any delay, let's start with the chapter construction. So first, obviously the name of the chapter is light. Then we have reflection. In the reflection we have two parts. Spherical mirror is one of the part. In spherical mirror we have concave and convex mirror, and we have another plane mirror. Very basic about plane mirror. Plane mirror we have already learned in our previous classes, so that's why plane mirror is kept only a brief portion. But we also have refraction. Okay, in the refraction we have a glass slab and we have lenses. These two are very important concepts. Then we have concave lens and convex lens. Both are there in our refraction parts. Today we will cover whatever is on our left hand side, whatever on our right hand side. We are going to cover that on Monday. Okay, because Saturday will be revision class and Sunday will be your test. So Monday we are going to come back to this chapter and we are going to discuss everything about refraction. Okay, today we are going to discuss everything about reflection. Obviously, now in the spherical mirror portion we also have few extra things. What are those? Terms related to mirrors, some terms that you have to remember. We have to also remember the image formation by these two mirrors, right? And sign convention. Sign convention is common. Whatever sign convention we learn for mirrors, the same sign convention is applicable for lenses as well. So you will learn it for only once. Okay, I'll explain how to remember the sign convention and then we will discuss mirror equation. Obviously mirror equation that is there in your syllabus, you have to solve some numericals based on this equation. Next is in lenses part we have image formation and lens equation. As I said, image formation is already taken care of. There will be some terms in lenses as well, but they are very similar to mirrors. Okay, but let's look into today's discussion. What are all the topics that we are going to discuss today? Main topics. Light and reflection, we will discuss basics about light, some reflection, we will revisit some concepts from reflection. Then we will discuss about mirrors, then obviously spherical mirrors. In spherical mirrors we will discuss principal rays, then image formed by convex mirror, image formed by concave mirror, and then we will discuss application of spherical mirrors, and there will be mirror equation as well. So after image formation we will discuss mirror equation and then we will discuss about the image application of spherical mirror. Okay, now let's move on. What is light? What is light? Light is a form of energy that gives us the sense of vision. Very interesting concept. So basically light is a form of energy. What is the meaning of energy? We know there are many energies exist in nature, right? One of them is light. Other than light we have sound energy, we have heat energy, very common energy, source of energy, right? From sun we are getting light as well as heat, both we receive from sun, right? That is the primordial source of energy, and this light actually gives us the sense of vision. What is the meaning of that? That we are seeing our beautiful world around us. That is because of light. This is possible because of light. If there is no light, we generally don't able to see. We are not animals. Some animals can see even in darkness. They have some special eyes. We can obviously use some infrared vision to see some objects which are emitting light at very low frequency, but the objects that we see around us is basically because of light. Okay, if there is no light we will not be able to see anything, right? Now let's look into the laws of reflection. So we have learned what is light. Now how light can travel from one place to another. We already know rectilinear propagation of light. Light can travel only in a straight line, right? Light always travels in a straight line. Now what will happen if we put a medium in the path of the light. Okay, so based on what type of medium we are placing in front of the light, okay, two things can happen. First is reflection. What is reflection means? When light is traveling from one medium to another medium, a portion of the incident light bounces back to the first medium. Okay, a portion of the incident light bounces back to the first medium from the boundary separating the two media. This is known as reflection of light. So basically light ray is traveling, okay, without any other medium it would have continued to travel in a straight line, but as soon as it is encountering a second media, for example in this case we have a glass medium with silver painted in the back side of this glass, we can see that some portion of the light is reflecting back. Okay, this some portion of the light is bouncing back. Basically we call this bounce back of light. This bouncing of light is called reflection. Okay, this is a real image from an experiment. So as you can see the ray as if they are traveling from this path. So this is basically, this is the image of the light. Okay, so light is basically reflected when you put another medium. Okay, now so this is called reflection of light. Bouncing back of light is called reflection. Okay, now this reflection obeys two laws. Okay, what are those two laws? First law of reflection is the incident angle theta I is the angle of incidence and theta f is the angle of refraction. Then from the laws of reflection we know theta I equals to theta r. We already learned about this, so I am doing it little faster compared to other concepts. These are already known to us, right? And we know that if a ray of light is falling on a medium and it is reflecting like this, then at the point of incidence, if we draw a perpendicular on the plane, on the point of incidence, if we draw a perpendicular to the plane, this is called normal. Okay, this is called normal. The name of that perpendicular is normal. Okay, normal means perpendicular. It is not nothing to related with normal and abnormal. Okay, normal means generally we means normal, everything is normal, everything is going okay. But here in physics and in mathematics, normal means perpendicular. Other name of perpendicular we call it normal. So here as you can see, it is said that it is a perpendicular on the plane, on the surface. Okay, so if you take a line on this surface, on the incident line, and if this is a perpendicular, then this angle will be 90 degree. Any line, in fact. You will learn about definition of normal in your future classes. I am not going into that detail, but you should know that normal means perpendicular on the plane. Okay, and we measure the angle of incidence with respect to the normal, right? So incident angle is measured with respect to this normal. Whatever angle it made with the normal, this is called incident angle theta I. Sometimes it is also denoted by only I. Okay, and reflected angle or angle of reflection or represented by theta r. Sometimes we generally represent it by only r. Okay, and first law of reflection says that I equals to r. Okay, if you are like old school, you can use theta I, theta r. If you are Gen Z, Gen Next, Gen Alpha, you can use I equals to r. Okay, so I is equal to r is more popular because it is short and small. So we like short and small. We don't like to write too much. So I is the new thing. Now let's move on. The incident ray, the reflected ray, and the normal drawn at the point of incidence all lie on the same plane. So incident ray, incident ray is this, reflected ray is this, and the normal that you have drawn, everything is on the same plane. Okay, everything lies on the same plane. That is the second law of reflection, which apparently is seems obvious, right? But might be not so obvious if you think it in terms of 3 dimension. Okay, 3 lines can be intersecting at the same point, but they still not be on the same plane. But for reflection, if you are drawing incident ray, reflected ray, and a normal at that point, they will definitely lie on the same plane. Okay, that is the law. Now let's move on to mirrors. Now we will discuss about mirrors. mirrors are objects that reflects light. There are two main types of mirrors. Okay, one is plane mirror, another one is spherical mirror. Okay, mirrors are also used to capture images of objects, right? So mirrors are also used to capture images of the objects. What is the meaning of that? You know that we use camera to capture images. So in one sense, even mirrors can be used to capture images. In fact, there are very large telescopes which observe the sky at night. They are based on mirrors. Okay, there are many different types of mirrors: spherical mirrors, parabolic mirrors. They are type of mirrors which are used to capture a beautiful space in the sky. Okay, so mirrors are also used, not only lenses. In case of our regular day-to-day cameras, we use lenses, but mirrors can be huge and they can capture objects which are very far. That's why there is a tendency in astronomy especially that we use mirrors to capture distant objects. Okay, now let's move on. Here we have plane mirror. In case of plane mirror, as we know, incident ray, reflected ray, this is normal. Now in case of plane mirror, angle of deviation is given by 180 minus 2i. This is only one formula you have to remember. But before I continue, what is the meaning of angle of deviation? So angle of deviation means there is a mirror, right? Here is a mirror located. But instead, if there was no mirror, then what would happen? If there was no mirror, then this light would have traveled in a straight line, constant, right? This ray would have traveled in a constant straight line. Now, if it would have been traveled like this, if you remove the mirror also, it will continue to travel in this direction. Now, but because you have placed the mirror, the ray is rotated some angle, right? So what is that angle? This angle is called angle of deviation, and this angle is denoted by d. Okay, so angle of deviation, either you can mention like this or you can mention like this, both are fine. Okay, so angle of deviation is the angle by which the ray rotates when you place the mirror. Okay, so this is called angle of deviation. It is given by 180 minus 2i. For our convenience, as I said, I will denote this angle as I, this angle is R. Now I is equal to R. Okay, this total angle is 180 degree. So 180 degree minus 2i. Okay, I plus R is 2i because I and R are same. So this is the formula that you might need to remember. If you don't need to remember, you can draw this diagram and recall it. Very easy to recall. Otherwise, you can simply apply this formula to solve some problems which might come in your annual exam. Okay, now let's move on. Now let's look into spherical mirrors. Okay, you have seen such images. If you have seen such images in some museum, in some gallery, okay, or the corner of a supermarket, okay, it is very common, especially this kind of things. This kind of mirrors you might have seen in your supermarkets, okay, or at the corner of a road. Okay, this is also common in some nowadays in the corner of a store, or if you are living in a multi-story building, at the basement you will see some mirrors, circular mirrors are installed. Okay, those are actually convex mirrors, part of a spherical mirror. Okay, so that you can see whatever who is coming from this side, who is coming from this side, both way you can see. So that is a way of mirror. We will see that in our application portion. Otherwise, these are all spherical mirrors. So whenever you don't see your image clear, like you see when you are standing in front of your regular mirror, okay, when you comb your hair or do some makeup, you don't do makeup, okay, sorry, okay. So when you comb your hair in front of the mirror, that is a plane mirror, okay, where your image and you and your image are almost same height, right? And if they are not, if they depend on the distance, if you move further away from the mirror, okay, the mirror sometimes gives you a inverted image, sometimes you will get a enlarged image, or sometimes you get a diminished image, then they are not plane mirrors. okay, and most possibly there is a high chance that they are spherical mirrors. Okay, we will see some uses, some daily applications where you have seen that mirror. Right now, if you are watching this video, mention in the comment below where you have seen a spherical mirror. Okay, some places which I may not have explained, I have already given you some explanation. Other than that, if you have seen spherical mirrors in any other places, please mention. Also, if you have seen the places I have mentioned, please don't forget to mention that in the comment below as well. Okay, now let's look into the basic definition of mirror. Okay, so spherical mirror is a part of sphere, one-sided silhouette. Okay, what is the meaning of sphere? Sphere is very simple, like a football, like a cricket ball. Okay, so those are spherical shape. Okay, there will be many spherical shapes that we see in our day-to-day life. Okay, basketball, okay, any ball basically spherical shape. If you take a mirror which is partly part of a sphere, okay, then that is called a spherical mirror. Obviously, you can see only part of the sphere. The entire sphere will be very huge. Okay, only part of it cut and it is given to you as a mirror. Okay, so it is not the entire sphere, it is only part of the sphere, right? Now, so as you can see, this is a complete sphere. Sphere, when we draw in two-dimensional space, it basically represents a circle. Right? Sphere is a three-dimensional object, but in our two-dimensional board, I cannot draw a three-dimensional object. Similarly, in your exam also, you will not be able to draw a three-dimensional sphere. But what you can do, you can draw a circle. So basically, this circle represents a sphere. Okay, and the portion that we have cut from the sphere, that is highlighted by this blue color. Okay, this blue color highlights the part of the sphere which is converted into mirror. Okay, here as you can see, this is a concave mirror and we have cut it from two portions, and there are different terms. We will discuss about that. But there are two types of mirror that we see in our day-to-day life. What are those two types of mirror? One is convex mirror, which is outward bulge. Outward bulge means when you stand in front of it, it faces towards you. You are standing, okay, then this curvature is towards you. That is convex. Okay, outward bulge. So this is an example of convex mirror. Okay, this reflecting surface, generally reflecting surface is denoted by the opposite to this cross side. Okay, so reflecting surface is this. So this is a convex mirror. Okay, and there is a concave mirror which is inward bulge. Okay, inward bulge means when you stand in front of the mirror, okay, it gives you a feel like a cave. You think if you have visited any cave in your life, or if you have seen any movies where people are going inside a cave, so cave is like a curved inside, right? Curved inside. From outside it appears to be curved inside. You can go towards it, right? Whereas bulged outward means it's like a rock wall which is coming towards you. This is coming towards you, whereas here you can go towards the cave, right? So you should remember this very beautiful analogy, that cave means where you can go in, it is curving inside, so you can go inside. So concave is basically when you can go inside, it's like a cave. Okay, so when you are standing in front of it, it's like a cave. Normally, by looking into a mirror, it is not so simple to identify from a distance. Only thing, how can you identify? You can go close to this mirror, and if you check, you will find this is a concave mirror or this is a convex mirror, because they have a very large radius of curvature. Later on we see what is radius of curvature. It is not very clear from even after touching it. Okay, so you have to be close to it to identify what type of mirror it is. So concave mirror, as I said, it has a curved inside. So you are standing here, you will see this is like a curved. Okay, so this is a concave mirror, this is a convex mirror. Okay, I hope the confusion, if you have any about convex and concave, that confusion clears right now. Okay, now let's move into the important terms about spherical mirrors. Okay, what are the important terms? Pole. The center of the reflecting surface of a spherical mirror is a point called pole. it is lies on the surface of the mirror, the pole is usually represented by letter P. So as you can see in this case, this is letter P. This is basically the center of the mirror. This lies on inside the mirror, lies on the mirror, on the surface of the mirror. Okay, and even if we draw this thick layer, only the reflecting surface is considered for the mirror. Okay, so this is the concave mirror and this is the convex mirror. Okay, clear? Now the point on which it lies on the surface and it represents the center of the mirror is the center of the mirror, not center of the radius of curvature, center of the sphere. Okay, it is center of the mirror. Okay, center of the mirror means if you consider this is the mirror, then the center will be considered the pole of the mirror. Okay, because when you are seeing in a 2 dimension, it will appear to be a circular piece. Okay, but actually it is a curved piece which is curved like this in a 3-dimensional way, right? Now, center of curvature. What is center of curvature? The reflecting surface of a spherical mirror forms a part of the sphere. This sphere has a center. This point is called center of curvature. So center of curvature is this. Okay, so the center, the sphere is part of the center. Okay, the sphere is part of the the mirror is part of a sphere. Sorry for the confusion. So the mirror is part of a sphere and that sphere has a center. That center is center of curvature. This does not lie on the mirror. This is outside the mirror always. Okay, this point is always outside the mirror. Okay, this is represented by the symbol C. Okay, now what else? Radius of curvature. Now what is radius of curvature? There is a center, so there will be a radius as well. So the radius of the sphere, so mirror is part of a sphere, that's why they are called spherical mirrors. So that sphere has a center, so the radius of that sphere is called radius of curvature. The radius of the sphere of which the reflecting surface of a spherical mirror forms a part is called the radius of curvature of the mirror. It is represented by the letter R. So in this case, this is the letter R. Either of them you can consider as the radius of curvature. Radius of curvature is represented by the letter capital R. Okay. Next is principal axis. Imagine a straight line passing through the pole and the center of curvature of a spherical mirror. This is called a principal axis. So principal axis is center of curvature and pole. If you consider a straight line that passes through both the points, center of curvature and the pole, then that line is called principal axis. Okay, so this is the principal axis. Principal axis, PAL, principal. Okay, principal, not principal. Now next is radius of curvature, principal axis. So this is this dotted line here is representing the principal axis. Now what next? Now let's look into another term, very important term. This is focus. Okay, so what is focus? For concave mirror, when rays parallel to the principal axis falls on a concave mirror, the reflected rays meet / intersect at a point on the principal axis of the mirror. This point is called principal focus of the concave mirror. So for concave mirror, when parallel rays of light, parallel rays to the principal axis, very important, okay, rays that is parallel to the principal axis, after reflection, okay, they meet at a point. Okay, that point, that every parallel ray to the principal axis always meet at this point, this fixed point. This is called the focus of the mirror. Okay, this point is the focus of the convex mirror, concave mirror, sorry. Okay, now if you may ask, what will happen if the rays are parallel but they are not parallel to the principal axis? This is a interesting question. Okay, I am not going to answer that. So suppose there are parallel rays which are parallel but they are not parallel to the principal axis. What will happen to these rays after reflection? Will they still focus on focus? Yes or no? So if you know the answer, you can write it down in the comment, or if you don't know, you can search in the Google and write the answer in the comment. Okay, so I'm just giving you an option. You can search, you can cheat a little bit, because this is not part of your syllabus, so you can cheat a little bit and tell me the correct answer in the comment below. Okay, now the focus of a convex mirror when rays parallel to the principal axis falls on a convex mirror, reflected rays appear to come from a point on the principal axis. This point is called the principal focus of the convex mirror. Now the question that I asked in our previous part, the answer lies in this term, principal focus. Okay, so the answer lies in this term, principal focus. Okay, that is the hint. So similarly, when parallel rays falls on a convex mirror, in this case they do not converge at a point, but instead if you are watching from this side, it appears that they are coming from a point behind the mirror. Okay, they appears to come from a point behind the mirror. This is virtual, obviously, because you cannot go behind the mirror like the way these rays are appearing to come from. So that is why this is a virtual point. Okay, so this is called principal focus for a convex mirror. Now let's move on to the next part. Now what is focal length? Okay, focal length is the distance between the pole and the principal focus. So focal length is the distance between the pole, in this case this is pole, so the distance between the pole and the principal focus is called the focal length. In this case focal length is this. Okay, it is denoted by a symbol small f. Okay, focus is denoted by capital F and focal length is denoted by small f. Small f means the focal length. Okay, and capital F is the focus. Okay, C is the center of curvature, R is the radius of curvature. Okay, so you have to be careful about all these terms. Now what is the relationship between capital R and F? Even though the definition, from the definition it appears that they are not related at all, because obviously center of curvature is a geometrical thing, right? It comes from the fact that the spherical mirror is part of a sphere. Right, spherical mirror is part of a sphere, and that sphere has a center, and that center, the distance of that center from the pole is radius of curvature R. And focus is when parallel rays, it is a more practical approach when you are talking about focus, that when the rays are parallel to the principal axis, after reflection they converge at a point. For a convex mirror, concave mirror, and for convex mirror they appear to come from a point behind the mirror. Okay, these 2 points are called focus. Okay, so for focus, what should be the relationship between focus and radius of curvature? There should be none, but actually geometrically it can be proven that you have this proof in your PU classes, or in your class 12th class, those who will study in CBSE in class 12, those who will study in PU board or state board. Okay, they will find it in their class 12th ray optics chapter. It is there, the derivation is there. In that you will see that radius equals to 2f. Okay, so that is the relationship between radius of curvature and focal length. So radius is basically 2f. Okay, now aperture of a lens. So what is the aperture of a lens? The diameter of the reflecting surface of the spherical mirror is called aperture. So diameter, so this is the spherical mirror that you see. This is nothing but part of the sphere. The sphere is like this. When we draw this mirror, we draw it like this, right? So we draw this like draw it like this, right? And this length is basically called the aperture. Aperture means the opening, how much diameter it has. Okay, how much light it can reflect at one go. It is important in astronomical uses. Okay, higher the aperture, better image you can capture from object which is very far away. Okay, smaller the aperture, it will be very highly contrasting image. Okay, so it will be very clear, crisp image, but it will not so bright. If the aperture is more, the image may not be highly crisp, but it will be very, very bright. Okay, especially for objects which are very far away, they are very faint, so you need a higher aperture object to capture that image. Then by using computer you can make it sharper. That is how we do it. Okay, that is how it is being done. Okay, many people are doing it. So you see lot of galaxies, different stars, far away gases, okay, in the cosmos. So those are basically, most of them are taken by either by a telescope in space called Hubble's telescope, or it is being captured by some telescopes which is located on Earth, and they are reflecting telescopes. Okay, now we have reached here. If you are still wondering that what you are going to do after your class 10th is over, which subject you should focus on, whether should you choose science or commerce, or if you choose science, then what next? Should you go for should you deem to be a doctor, or you want to be an engineer? If you are still confused about these choices, don't worry, Diksha is presenting DSAT, okay, Diksha Scholastic Aptitude Test, where there will be a 60-minute class. Out of that 60-minute class, 45-minute lectures will be there and 15 minutes doubt clearing session. After this lecture is over, you will be given a 1-hour test, okay, based on that 1-hour lecture. Okay, once the lecture is over, your doubts are cleared, then based on that there will be a test given to you, and based on that test result there will be a counselor available. He or she will guide you completely for your correct career path, okay, so that you are on the correct path, and they will guide you what to do. And also we only have a limited seats. Every Sunday it is being conducted across Diksha campuses. So if you are still wondering, you can fill up the form, okay, and you might enjoy some great discounts as well. So what are you waiting for? Don't wait any further, just fill this form, and our representative will contact you for any further details. Okay, now let's start, continue with this journey. We are going to discuss about principal rays. Okay, what is principal rays? A ray parallel to the principal axis after reflection will pass through the principal focus in case of a concave mirror, or appear to diverge from a principal focus in case of a convex mirror. So what is this? So basically now we are slowly going towards the ray diagram part, where we have to draw the ray diagram. Now to draw the ray diagram, we know that an object can emit unlimited number of rays, right? Unlimited number of light can come out from an object on a point source. Okay, so that is the basic definition. So if you know that what I am talking about, if you have a point source, from this point source there can be 100 number of rays can travel, okay, if not more. Now which of these rays you will consider to draw the ray diagram? Okay, to draw the ray diagram we cannot consider all possible rays that is coming out from a source. We will only consider a few rays. Those rays are called principal rays. Okay, the rays that we are going to use to draw ray diagram is called a principal ray. Okay, now there are few principal rays. We will learn about them one by one. The first principal ray is when a ray parallel to the principal axis falls on a concave mirror. After reflection it passes through the focus directly. For concave mirror. For convex mirror, after reflection it appears to come from the focus. So what is the meaning of appearing from? So suppose you draw a straight line which is parallel to the principal axis, then you join the focus and this point, okay, and then you extend this line. Okay, if you extend this line, then that line will represent the reflected ray. Okay, now the law of reflection is valid for all type of objects. Maybe it's a plane mirror, maybe it's a spherical mirror. For all type of objects the law of reflection is valid. That you have to remember. Even for non-uniform surfaces, law of reflection is still valid. The reflection may not be regular, it will be diffused reflection, but still the law of reflection is valid. Now one important thing is that when you draw when you join the point of reflection with the center of curvature, this will give you the normal. This is the normal. For any point of reflection, this will always be the normal. Okay, this will always give you the normal. That is one trick about spherical mirrors. Okay, when you join center of curvature to any point, that will give you the normal. So in this case, this is the normal, so this is the angle of incidence, this is the angle of reflection. Obviously they are equal. Okay, this has no much physical meaning for particular this class. Maybe in future you will learn something about this thing. Okay, but you should remember that incident ray, if you join C and point of reflection, then obviously this will represent the incident angle and reflected angle. Okay, clear? So parallel to the principal axis passes through the focus. Parallel to the principal axis, you have to join the focus and then extend it. Sorry, join the focus and then extend it. Okay, this is how you continue to draw the ray diagram. Next point, at least two principal rays you have to follow. What are the two principal rays? A ray passing through the principal focus of a concave mirror, or a ray which is diverted towards the principal focus of a convex mirror after reflection will emerge parallel to the principal axis. This is also very important. Any ray which is passing through the focus, any ray which is passing through the focus after reflection, it will emerge out to be parallel to the principal axis. In this case, it is going towards the focus, but it has not reached the focus before reaching focus. Okay, it has encountered the mirror, so it will reflect back. Okay, and this will be parallel to the principal axis. So whatever you have learned in your previous case, this is just the opposite. Previous case, parallel ray after reflection passes through the focus. Okay, and this is ray passing towards the focus after reflection becoming parallel. Now one important thing about ray diagram, that you have to put the arrows. Okay, if you simply draw this ray diagram, okay, without the arrow, this has no meaning. Okay, what is the direction of light? Is it going from here to here, or is it going from here to here? Both is correct, but you have to show them that, okay, I want to draw this ray. So the ray diagram definitely requires an arrow. There are two more principal rays. I will just briefly discuss about them. What are those? So when the ray passes through the center of curvature, okay, after reflection it comes back straight. It's kind of normal incident. Okay, when the ray passing through the center of curvature, it comes back through the same path that it came from. Okay, here if it is going towards the center of curvature and hits the mirror after reflection, it goes back to the same path it came from. So you can consider this kind of reflection as normal reflection. Okay, now what else? There is one more ray when it incident at the pole. Okay, obliquely on the principal axis towards the point P on the pole, on the concave mirror, convex mirror, it's reflected obliquely. Okay, so basically whatever angle it incident, the same angle it will reflect. We will never use this ray in our discussion, but you should know this is also a principal ray. In some cases, some difficult cases maybe in future, you have to remember this is also a principal ray. Right now, image formation by a concave mirror. So there are two cases of convex mirror, and there are few cases for convex mirror as well. So what is the convex mirror? In case of convex mirror, basically there is an object which is at infinity. What is the meaning of infinity? Infinity means the object is very far away. For example, you can take the moon, which is located very far. For Earth, it is almost at infinity, very far away, right, for a normal mirror. So when the object is at infinity, that means, for example, a moon is you can consider to be an object at infinity for a normal convex mirror. Okay, sun is considered to be an infinity, but sun size is bigger. So if you consider any star which is very far away, then that you can consider to be an object at infinity. Okay, so small objects which is very far, you can consider them to be an object at infinity. So the ray of light coming from that object is parallel to the principal axis. So after reflection, what will happen? The ray of light will appear to come from the focus, and that point you can consider to be the image. Okay, this is the image. This is the location of the image where two rays are meeting or two rays are appear to come from. That point is called the position of the image, right? So for an object at infinity, the image will be exactly at focus. okay, and for any other object which is located anywhere on the axis, okay, the image will be upright. Obviously you can see it is in this direction, upright, okay, and it will be diminished highly. In this case the image will be highly diminished. As you can see, the object is this big and image is very small, so image is highly diminished. But any other objects will be diminished, image will be diminished, upright, okay, and virtual. Why is virtual? Because it is happening in the behind mirror. So for example, when we stand in front of the mirror, our image appears to be virtual, right? Because we cannot actually touch the image, right? We cannot take the image, we cannot place a scanner and we can take the picture from behind the mirror. It is not possible. But if the rays are actually meeting at a point, we can place the photographic plate and we can capture that image, right? So in this case it is not possible. So it's a so in this case this is a virtual image. Okay, now let's look into the characteristics at one glance. So object is at infinity, image is at focus, behind the mirror, highly diminished, point sized, virtual and erect. Okay, in case of between infinity and the pole P of the mirror, between P and F, behind the mirror, diminished, virtual and erect. Okay, so this is the property that you have to remember. Virtual convex mirror always produces virtual image. Okay, convex mirror always produces virtual image of real objects. Okay, now let's move into the image formation by concave mirror. Okay, so object is at infinity, first case. So object is at infinity, so basically the same thing. The object is very far away and the rays coming from that object will be parallel to the principal axis. In that case, obviously the image will be formed at the focus. After the parallel rays, everyone will focus at the focus by the definition of focus itself, that when the rays are parallel to the principal axis, they all converge at a fixed point and that point is called principal focus. Similarly, if the rays are parallel to the principal axis, after reflection they will all converge at a single point. Obviously the image will be very small, okay, compared to the actual object. The image will be very small, so highly diminished. Okay, even you can say it's a point size object, point size image, and it will be at the focus. The image will be real and inverted. Why real? Because it is actually meeting. In this case the rays are actually meeting at a point, so the image will be real. If you place a photographic plate here, you can take that image, you can capture that image. Okay, so that's why this is a real image. Okay, and inverted because convex mirror always forms real inverted images, so that's why it is called real image. Okay, real images for convex mirror are always inverted. Okay, concave mirror can also form virtual images, but that is not inverted, that is erect. That is erect. Yes. Okay, we'll see that. Object beyond C. Object beyond C will be when the object is located at some point AB and you have to take this ray, pass it through focus, then you have to take another ray, pass it through the center of curvature. This ray will come back again through this path, and wherever they intersect, that will be the point of the image. Okay, so you are starting from here, so this will be your this will be the bottom of the arrow. Now how to draw this kind of ray diagrams? So there is a tip about this. First you take a straight line, draw a straight line. Okay, say you draw a 10 centimeter or 15 centimeter straight line. Then you take a point. Okay, for convex mirror, concave mirror only I am talking about. Convex mirror ray diagrams I have never seen in they have asked you to draw convex mirror ray diagrams, but problems and questions based on a given ray diagram might come. Okay, but in the exam to draw a ray diagram, okay, mostly concave mirror is coming. So you have to take a point as your pole and another point as the center of curvature C. Try to keep this distance minimum 6 centimeter. Okay, so what you will do, you will take your scale and measure this 6 centimeter. Put your compass here, the needle of the compass here, the pencil of the compass here, then draw the sphere like this. Okay, so this is how you draw the ray diagram. Okay, so you already know this is my C, this is my P, and point between these two is F. that is 3 centimeter. Okay, now you take an object which is far away from the center of curvature. Now you have to use 2 rays. What are all the rays? First ray is this parallel to the principal axis, which is parallel to the principal axis. After reflection, it passes through the focus. Okay, use the scale, just draw it. Next is the ray that passes through the, you can take 2 rays, any one is fine. In this case, since they have used this ray, I am using this ray also only, same simple ray. Okay, if you are taking this ray, it is going in this direction, then it is reflecting back in the same direction. So this is your image. Okay, so for this location it is okay. For a special location, that is when you place the object exactly at C, the image is slightly difficult. I will not going to discuss that today. I will discuss tomorrow's revision lecture. In our revision lecture, I will explain how to draw the ray diagram when we keep the object exactly at C. Okay. Other than that, this is the common procedure. You can draw this method for any point beyond C, any object kept at between C and F. So both cases this method is fine. This is the common method, and drawing the mirror part is same for all the cases. Okay, only there is a special trick that you need to know for when the object is kept at C. So if you want to learn that, then you have to watch my revision class tomorrow, where I will discuss about how to draw the ray diagram for object when it is kept at C. Okay, now, so object kept at C, as you can see, the image will also be forming at C. Okay, so this is the special diagram. You cannot draw the diagram the way I showed in the previous case. If you try to draw the diagram like this, you will never get the location of the image exactly at C. It will either slightly left, slightly right, or they will not match at focus. So there are few drawbacks of this, so you have to know how to draw it smartly. Okay, in some cases this diagram might come, so you have to be careful about that. Now what next? So this is, I said, this diagram also you can draw, but in this case, when the image is between, object is between C and F, you keep the size of the object smaller. Okay, because the final image will be extended, it will be bigger than the object, so you have to keep this object smaller. In previous cases, the size of the object does not matter. Okay, in this case you have to keep the size of the object smaller. So previous cases, suppose you use the object as 2 centimeter arrow, then in this case you will use a 1 centimeter arrow. Okay, because you have to keep this mirror as close to the edge of the paper, and you have to rotate the paper. Obviously you have to rotate the paper so that you can use the full length of the paper. Okay, and in this case the image will be formed slightly further from the center of curvature, and it will be inverted. Okay, so this is the case where the ray, same case. Okay, same 2 rays you are drawing. One ray is parallel, after reflection passing through the focus. Another you are joining the center of curvature and the object, and then extending this side, extending this side, extending this side, extending this side. So both is fine. Okay, now another case is, this is very, very important, when the object is kept at focus. When the object is kept at focus, after reflection, the rays do not meet. They all go to infinity because they become parallel to each other. Okay, now in this case, the rays are parallel to each other, so the distance is constant after reflection. So they do not meet. They meet at infinity. So the image is highly enlarged. Okay, image is highly enlarged and obviously inverted and real. Okay, so this is a special case where the image, you will not be able to see the image. This is exactly opposite to that. You have learned when the object is at infinity, the image is at focus. When the object is at focus, image is at infinity. Okay, so vice versa. Right, now if the object is very close to this between focus and pole, that is, object is very close to the mirror itself. Okay, they have used this ray. I don't suggest to draw this ray. Okay, you can use this ray as well. Okay, and you will get the same result. Don't worry. Okay, this is the simplest ray, so they have continued to use that, but I suggest you should keep on using this ray. This ray is not required, this complicated ray is not required. Okay, you can continue to use this ray parallel to the principal axis. After reflection, obviously it will pass through the focus. Okay, so that is also fine, right? And if you extend that backwards, so now you see that these two rays are not going to be converging anyway in this direction. So if you trace them backward, they will converge at some point A dash. So basically this is a virtual image. Okay, so, convex mirrors only produce virtual image, whereas concave mirror can produce real as well as virtual image. So a mirror which can produce real and virtual image is a concave mirror. So there is chance that there might be some objective question based on this. Which of the following mirror produces only virtual images? Which of the following mirror can produce real as well as virtual image? Okay, so this is very common because plane mirror can also produce only virtual images, it cannot produce real images. So but if they give the question that which of the following mirror can produce only can produce virtual as well as real images, they will give you option concave mirror, convex mirror, plane mirror, all of the above or none of the above. Okay, so you have to be careful, you will choose only what? Concave mirror. Okay, concave mirror produces real as well as virtual images. Okay, now this is the table of diagram. Okay, at infinity, at focus, highly diminished, point size, real and inverted. Beyond C, between F and C, diminished, real and inverted. At C, same size, real and inverted. Between C and F, beyond C, enlarged, real and inverted. At F, at infinity, highly enlarged, real and inverted. Between P and F, between the mirror, enlarged, virtual and erect. So here is one catch, that you have to remember that when the object was at infinity, okay, the image was at focus and it was very, very small. Now from infinity it came between C and infinity, so the object is now closer to the mirror. Obviously infinity is very, very far away. Now between infinity and center of curvature, the object is obviously closer to the mirror, right? In that case you can see that image is still diminished, but it is not a point object, it is somewhat bigger. So as the object is slowly walking towards the mirror, you will see that, so initially when it started at infinity, the object, okay, suppose the object is like a man, it started at infinity, it slowly started walking towards the mirror. Okay, so at infinity his image was at focus and it was very small. Now it came between infinity and C. At this point the image is slightly bigger and image is between focus and F. Between focus and C. Okay, now it slowly walked, it reaches exactly at C. At this point its image actually matches its size, so image is now exactly as same size as the object. Okay, now as soon as it crosses C and goes very closer to the mirror, in that case what happens is that the image is now bigger. So image started getting bigger and bigger. Now the object keep on walking, it reaches the focus. Now at this point the image becomes infinitely large. Okay, so the image becomes infinitely large now, so it has reached the limit. Now as soon as it crosses the focal length, now image has nowhere to go in the behind, so image flipped and it goes backside. Okay, so you can remember like this. This is a very interesting table. You can take a screenshot, save it, okay, for your future reference, or you can copy it in your notebook so that you don't miss out on any important concept. Okay, now let's move on to the sign convention of mirror. Very important sign convention. Many students struggle in sign convention, so I am going to explain it with simple thing. If you are familiar with your coordinate system, that is, we have two axes, y axis and x axis, right? This is our coordinate system, x, o, x dash, y, o, y dash, right? So this is our coordinate system, right, for which we used to draw the graphs. Now in this case we know that anything along this direction is positive. So +1, +2, +3, they all lie on this side, right? Anything along this axis is negative. -1, -2, -3, they are all along negative x-axis. Similarly, along upward direction, everything is positive. Everything is negative in the downward direction, right? So same thing we will use in our sign convention for mirror. Okay, so what we will use is, we consider that this is basically our origin. This is our origin, and this is imaginary y-axis. Okay, and this is our x-axis. Okay, so anything in this direction, any point in this direction is always positive. Any point on this hand side, our left hand side of the screen, okay, left hand side when we are facing the screen, that is negative, right? Anything on our upward side is positive, anything our downward side is negative. Clear? This is the sign convention. If you remember this, only thing that you have to draw this diagram. Sometimes they ask draw the sign convention for spherical mirrors. You have to draw this diagram, okay, or they might ask you explain sign convention for spherical mirrors. Then you have to mention that anything along the positive x-axis is positive. You have to draw this diagram first, then you have to explain that anything along the positive x-axis is positive, anything along the negative x-axis is negative, anything along positive y-axis is positive, anything along the negative y-axis is negative. Simple as that. Okay, so basically this is the coordinate system, so we can measure the distances correctly. That's it. Mirror formula. Okay, so mirror formula is the equation that is representing all the relationship between object distance, image distance, etc. So we will explain that in a while. What is that? First of all, this formula is valid for all situations, for all spherical mirrors, for all positions of the object. You must use the new Cartesian sign convention, the sign convention that we discussed, okay, while substituting the numerical values for u, v and f and r in the mirror formula for solving problems. That's it. Now let us understand what is u, v, r, f that we are talking about. So first of all, we are considering a concave mirror. Okay, so we are considering a concave mirror. Our object, whenever we draw a ray diagram or whenever we start solving problems, our object always lies on this side. Okay, that is along negative x-axis, right? This is our negative x-axis. The distance between the object and the pole, okay, the distance between the object and the pole is called u. Okay, now wherever the image is located, suppose the image is located here. Suppose the image is located here. Whatever is the distance between the pole and the image is called the image distance v. Okay, object distance is denoted by the symbol u, image distance is denoted by the symbol v. Okay, wherever the focus is, okay, the focus, that distance is basically our f. I already said focal length is denoted by the symbol f, and radius of curvature of the mirror, which is further away from this side, that distance is basically represented by r. Now we already know the relationship between f and r, right? F is equal to r by 2. Okay, sometimes we will use this formula directly, sometimes we will include this r as well, but for most purposes this formula is okay. Now remember that whenever you are inserting the value of u, v, f, etc., you have to use the proper sign convention. So for example, in this case, in our previous case, we have seen that object distance is always negative. So this is the object. Okay, so in this case, this is u, right? Object distance is always negative. U is always negative. You have to remember whenever you are solving problem, even though the negative sign cancels, you don't have to worry about it. Negative sign always cancels. Sometimes it may cancel, sometimes it may not cancel. So u is always negative. Okay, now based on what type of mirror you are using, okay, if you are using a concave mirror, focal length will be on this side, So for a concave mirror, focal length will be negative. Okay, so for a concave mirror, focal length will be negative. For a convex mirror, which is like this, okay, the focal length will be positive. So focal length is in this side. So focal length is positive for a convex mirror. For a concave mirror, focal length is negative. For a convex mirror, focal length is positive. Okay, so this is the basic things that you have to remember. Okay, for a concave mirror, focal length is negative. For a convex mirror, focal length is positive. Object distance is always negative no matter what type of mirror you are using. In fact, if you remember this sign convention, it will help you to solve problems in lenses part as well. Okay, in lenses also, concave lenses, focal length is negative. For convex lenses, focal length is positive. Object distance is negative in both cases. So they have some similarity. If you remember it once, you can apply it twice, right? Double dhamal. Okay, buy one get one free, right? Now another thing is magnification. Magnification is produced by a spherical mirror, gives the relative extent to which the image of the object is magnified with respect to the object size. So magnification means we say diminished, magnified, okay, or enlarged. So by how much amount, how much enlarged, by how much diminished it is. So that is given by this relationship V minus V by U. Okay, so magnification is given by this symbol minus V by U. The negative sign here, if the actual magnification, you have to use the signs, whether V is positive or negative, U is always negative. So you have to include the signs to calculate the magnification. And after you complete the calculation, if the M is still negative, then that is an inverted image. Now inverted image means what? Inverted image means the image is real image. Okay, for real images M is negative, for virtual images M is positive. Okay, so you have to remember that a negative sign of the value of the magnification indicates that the image is real. A positive sign of the value of the magnification indicates that the image is virtual. Clear? Now let's see one small example. An object 4 cm in size is placed at 20 cm in front of a concave mirror. Okay, concave mirror is given. So mirror, we can simply draw concave mirror. Okay, size of the image, size of the object, okay, object height is given 4 cm. Okay, placed at 25 cm in front of the mirror. So U is equal to minus 25. So whenever you are using the variables, write the sign immediately. Okay, in front of the concave mirror of focal length 15 cm. So focal length, concave mirror is given, so the focal length will also be negative. Focal length is on this side, so focal length will also be negative. Okay, what distance from the mirror should a screen be placed in order to obtain a sharp image? Okay, so basically you have to calculate what should be the V. Okay, so how to calculate that? 1 by U plus 1 by V equals to 1 by F. We will use this formula to calculate the V for the first part. First we will calculate V, then we will see whatever second part is given. So U is minus 25 plus 1 by V equals to 1 by minus 15, or 1 by V equals to 1 by minus 15 plus 1 by 25. Why plus? This was already negative, so it goes to the right hand side and become positive now. What else? So 1 by V equals to 15 and 25. What is the LCM of 15 and 25? It has 3, it has 2 5s. So it has 3 into 5, it has 2 5s. So we can just simply write 75. You can say this is the LCM. Okay, so this is the LCM 75. So minus 15 will be minus 5. Okay, and 25 will be 3. Okay, so it will be minus 2 by 75. or V equals to minus 75 by 2. Okay, so it will be 37.5. Okay, so this is V. Okay, so you have calculated V, so you have to place the screen on the same side as the object at a distance 37.5 from the pole. 37.5 centimeter from the pole. Okay, now find the nature and the size of the image. So the nature is what is the nature? So image is negative, V is negative. So negative means on the same side as the image object. So it is a real image. Okay, this is a real image because it is forming on the same side as the object. So real image. Now magnification, find the magnification. Magnification is minus V by U. What is V? V is minus 37.5 and U is minus 25. So it will be 5 minus cancels, 575. Okay, let me replace it. You can use whatever way you want. I am using a smart way. I am replacing this 37.5 by 75 by 2 times 25. Why? Because this will be easy for me to cancel. Okay, so it will be minus 1.5. This negative sign represents this is a real image, inverted image, obviously. So what is the size of the image? Size of the image will be H equals to 1.5 times 4. Okay, that is 6 centimeter, and this is inverted. Okay, while calculating the size, you can ignore the sign. Just you have to mention this is inverted image. Some application of spherical mirrors. What are the applications? Obviously, as I said, this is one of the most common telescope, Cassegrain telescope. You can check that. This is very common type of telescope to check moon. If you have ever wondered, if you have ever gone to some astronomical expeditions and they have shown you some beautiful images using a telescope, basically this kind of telescope, then might be this is a Cassegrain telescope where the image of the moon is very common to on display, right? Some stars can also be seen using this telescope. Okay, and Cassegrain telescope basically uses two mirrors. Okay, one is this kind of concave mirror and there is a convex mirror. Okay, so this is a convex mirror. Concave mirror basically reflects the main light from the distant object. Okay, then before it reaches focus, there is a convex mirror that focuses back in the opposite side and you get an image here. Okay, and through this you can check the light, okay, in your eye. Okay, so there are different mechanism, but this is the basic fundamental principle of the mirror. Using so basically a telescope can be constructed using a mirror as well. Okay, and in fact this is much bigger. So if you are constructing using a lens, the mirror the telescope is smaller, but this accuracy is small. Okay, but if you are using a Cassegrain telescope like telescope which has a very bigger aperture, then you can see even farther away from whatever we can see. Okay, that is the beauty of mirror telescope. So this is an image taken by a mirror telescope. Okay, beautiful image that we see on our many of the places. You may have seen this image. This is nothing but taken by a Cassegrain telescope. Okay, now yes, so as I said, in supermarkets or the corner of your home you might have seen this kind of mirrors. This is a convex mirror. Okay, this gives you a view of total view of from this side as well as that side. Whenever you are coming from some angle, you can see whoever is on the other side. Okay, because it has a very high area of reflection. Okay, because it's a convex mirror, the ray of light coming from this side after reflection can reach this side. Okay, similarly any ray traveling from this side after reflection can reach that side. So if you are standing here, okay, the person who is standing there, they can see you are here and you can see he is there. So it is to avoid any accidents on road. Okay, so in case of blind curves, basically when you cannot see whoever is on the other side of the road, there is a L-shaped road or a Z-shaped road. In that case, you install this kind of mirrors, okay, convex mirrors. Also, I don't know how many of you mentioned when I was actually talking about it, the rear view mirror of any car or any cycle or bicycle or scooter or motorbike, whenever you see a rear view mirror, that is a convex mirror. Okay, so that is a convex mirror. Why that is a convex mirror? Because it has a large field of view. So basically when you are driving, you can see a lot behind you, whoever is coming, which side he is, or he is driving right or left. Okay, so you can see whoever is behind you using that mirror. So that is why convex mirror is very useful when you are using rear view mirrors. Okay, so rear view mirrors are very popular and used in your any vehicles. So this is the most common application of spherical mirror. Okay, but in this case, as we have seen, convex mirror always produces smaller images, so it might give you a feel that the object is very far away from you. Okay, the car or the bike, whoever you are seeing behind the mirror, if it is appearing small, you might think, oh, the car is very far away. Actually, it is not that far away. So that's why sometimes there is written a precaution. The objects are closer than they appear. Why so? Because our perception of objects is based on plane mirror. So plane mirror, if you are standing very far, your image will be very small. Right, whoever is farthest from the mirror, the image is appearing to be very, very small. So that's why it gives you a sensation that the object may be very far away. Actually, it is not super far. It is actually closer than it appears. That's why you have to be careful about it. Okay, when you are looking in a rear view mirror. Okay. Now, if your mother or your sister or you yourself use a makeup mirror, okay, so that makeup mirror is basically a concave mirror, because we know that when the object is kept closer to the focal length, okay, it produces a virtual and enlarged image. Okay, even in surgery also the doctors uses some special mirrors to see if something is inside. That type of mirror is basically a convex mirror which enlarges the object, especially dental surgeons. Okay, they use a mirror to see what is inside your teeth. So that is a convex mirror. Okay, concave mirror. Concave mirror produces virtual and enlarged image when you are seeing yourself in that mirror. So that's why convex mirror are used in makeup, in some cases shaving, okay, also dental purposes. So that is the very common uses of mirrors. So we have discussed about entire chapter of reflection, image formed by reflection, image formed, and application as well. So I hope you enjoyed our lecture today. This is the homework for our next class tomorrow. During our revision, I will give you the answer for these two homework questions. So there are two homework questions. This is first question. You can pause the video, read the question, answer the question in the comment below. Tomorrow during our revision class, I will give you the answer. Right? Now, this is the second question. This is a numerical type question. Read the question. I am reading you for you. A concave mirror produces 3 times magnified enlarged real image of an object placed at 10 centimeter in front of it. Where is the image located? So you are given the magnification. You are given the position of the image. Okay. Then also it is said that a real image. Now based on that you have to calculate V. Okay, so based on that you have to calculate the V. Okay, very simple question. If you think focal length is not given and it is not even required in this case, they might ask you what is the focal length of the mirror. So that will be something interesting. That will be little bit longer, but this question is very simple and short. Okay. Now if you are still wondering after the entire class that I am still not sure that what I will do in future, okay, after my 10th is over, should I go for science, should I go for commerce, or if I go for science, then what should be my focus on? Should I go for engineering in future? Should I study for medical? And even if I am ready for our medical or not, okay, so not every subject, you have to remember that not every subject is for everyone. Okay, some wrong career decision right now may ruin your entire future. So what you have to do, you don't worry, you have to take Diksha Scholastic Aptitude Test, that is DSAT, which is being conducted at Diksha campuses every Sunday. Seats are limited. Okay, during these classes 60 minutes of lecture will be there. During that lecture 45 minutes of class and 15 minutes of your doubts, whatever you might have during the class. Once everything is done, based on that lecture there will be a 1 hour test, and based on that test result we will tell you what is best suited for you. Okay, now whether to opt for that or not, that is up to you obviously, but if you take admission on our Diksha campuses and if your DSAT score is good, you will get a good discount as well. Also, to avail the discounted offer, you have to fill this form and our representative will contact you. So what are you waiting for? Don't wait any further. Fill this form immediately and get ready for a bright and very, very secure future. Now also I request you to subscribe to our channel if you have not done so, and like this video and share with your friends. I will be back with revision class along with Jasmine ma'am. I know many of you are waiting for Jasmine ma'am, so we'll be back together during our revision class, and then Sunday there will be a mock test, right? So we'll be back. Till then, bye.